Ms. Gayatri?
Yes, I'm here. Can we start?
Okay, good morning, Ms. Gayatri. Happy to be here. Dr. Ayesha, we have Ms. Gayatri here in our team. She'll be introducing herself and she'll be the MC for today. So we'll be going live in YouTube as well. We are already live. Can I confirm from you that we are ready, Dr. Ayesha?
Hello, Ms. Ayesha. Can we start?
Yeah. Is my screen visible?
Yes, your screen is visible, but before that, I'd like to give a little intro about you. Can I proceed?
Yes, proceed.
Yeah. I now request everyone to mute your mic and switch off your video to avoid any kinds of inconvenience. Thank you. Hello everyone, a very good morning to one and all gathered here. I'm Gayatri Karnataka, and on behalf of Ryan Publishers, it's my greatest pleasure in welcoming you all to today's one-day international webinar on the topic, Role of Internet of Things in Mobile Communication. The participants can post your queries and clarifications in the chat box, and I would like to inform that the feedback form for today's seminar will be posted in the chat box. It's now time to get into the session, and joining with us today is Professor Ayesha. Welcome, ma'am.
Thank you.
Ms. Ayesha is currently working as an assistant professor in the Department of ISC, Mysuru. Our resource person has teaching experience of more than 12 years, and her area of specialization is communication network and Internet of Things, image processing, data mining, and cloud computing. She has published and presented around 35 papers in both national and international journals and conferences. Our resource person is a member of editorial boards for funded projects and government bodies. She has been a recipient for many awards, and to mention Best Project of the Year in Seminar and Exhibition held at BIET, and won Best Paper Award at CSI National Level and Student Convention. We are extremely honored and delighted to have such an insightful person amidst us. Thank you very much for joining us today, ma'am, and the session is now yours. Thank you.
Thank you, madam. Thanks for the introduction. Is my screen visible to all the participants?
Yes, ma'am. Your
Can I
screen is
proceed, madam?
Yeah, sure. You can do it.
Yes, good morning everyone. I, Ayesha, working as assistant professor in Department of Information Science and Engineering, feel honored and privileged to share my knowledge on the role of Internet of Things in mobile communication. The fast-moving field of Internet of Things offer a growing selection of supporting components and connectivity methods, and for developers, it can feel like the countryside change daily. At the heart of the explosion of Internet of Things and the IIoT is the industrial IoT, is wireless technology made possible via radio frequency. This technology enables devices to communicate with one another without being physically connected. With this root in the early 20th century, radio frequency technology is not new, but it has grown to include cellular devices and other advances, keeping in stride with an enormous demand of new consumers and industrial application. Technological enhancement that support this incredible growth include the speed and bandwidth of the underlying network, extended battery life of IoT devices, broader capacities of wireless communication, protocols, and more secure management of devices and networks. These advancements have allowed a significant number of industries to replace expensive and often unreliable wired communication with wireless communication. Let me start with what is wireless. Wireless means communication without the use of wires other than the antenna, the ether taking place of wires. Radio means exactly the same thing. It is the same process. Communication by wireless waves may consist of SOS or other messages from a ship at the sea, or the communication may be simply the reception of today's 10 music artists are connecting to internet to achieve their email. In this particular diagram, you can see that the father of your radio invention was your Marconi, transmitted Morse code signals using your radio waves. In the early 1849, the telephone was invented, and within 50 years, it was an essential item for homes and offices, but threatened impact the flexibility and privacy of the device. Then came the mobile phone in 1973, which was created by Motorola, which was a kickstart by the Martin Cooper in 1970, who created or invented the handheld device capable of two-way communication wirelessly, which was called as your first generation mobile phone. The world's first commercial cell phone was designed by Motorola. The first wireless telephone conversation occurred in 1880 when Alexander Graham Bell and Charles Sumner Tentar invented the photophone, a telephone that sent audio over a beam of light. The photophone required sunlight to operate and a clear line of sight between transmitter and receiver. In February 1896, Marconi journeyed from Italy to England in order to show the British telegraph authorities what he had developed in the way, and he patented it in June 2 of that particular year. The first G, or the 1G network, to the first generation of wireless cellular telecommunication or your mobile communication was an analog telecommunication standard that were introduced in 1980s and continued until being replaced by 2G digital telecommunication. The main difference between these two mobile cellular generation is that the audio transmission of 1G network, where they use the analog portion, while 2G was entirely the digital one. In the 1G mobile communication system, which was developed by the Nippon Telephone and Telegraph Company in 1977, literally used your analog signals. These frequencies would be the key features of your 1G, wherein the frequency was categorized as 800 megahertz to 900 megahertz. The bandwidth which it utilized was 10 megahertz, and the technology which, as I have already told you, was utilized was your analog switching. Your mode was only voice was transmitted, and the access time was your frequency division multiplexing. When we move on to the evolution of the communication, that the second one was your 2G or your second generation cellular network. Your 2G cellular network were commercially launched on GSM standards in Finland and Radio Ninja, which is now a part of Ayesha in 1991. Three primary benefits of 2G networks over the predecessor over the first 1G was digital encrypted phone conversation, at least between the phone, mobile phone, and cellular base station, but not necessarily the rest of the network. Significantly, more efficient use of radio frequency spectrum enabling more users per frequency bandwidth, and data service for mobile starting with SMS text messages, whereas in your 1G, as I already told you, we used only your voice message, whereas in your 2G, along with your voice, we started with your SMS text messages. Your 2G technologies enabled various networks to provide services such as your text message, your picture message, and your MMS, that was your multimedia your messages. After 2G was launched, the previous mobile wireless network system where radio reactively doubled to 1G. While radio signals on 1G networks are analog, radio signals on 2G networks are digital. Both systems use digital signaling to connect the radio towers. We call them as towers for a layman understanding, but actually it is a base station to the rest of the mobile system. With general packet radio services, 2G offers a theoretical maximum transfer speed of 40 kbps with EDGE. EDGE is also called as your Enhanced Data Rate for GSM Evolution. There is a theoretical maximum transfer speed of 384 kilobytes per second. And the key features are the key features of GSM when compared to 1G have been enhanced over here, and the messages, as we have seen, it is using the frequency as 900 to 1800. It is digital switching, it is using your GSM, it is using your time division multiplexing, it is using your short message services, and many more features were included when compared to your 1G. Next, we move on to your 3G, which is also called as your Universal Mobile Telecommunication System or your wireless mobile telecommunication technology. It is the upgraded form of your 2.5G GPRS. After 2G, we had an extended version of 2.5G and 2.75G Edge network. These two have been eliminated in this particular slide because these had similar features with few or more enhancement in the frequencies and bandwidths. So here I have directly started with your 2G and jumped on to your 3G. For faster data transfer, this is based on the set of standards used for mobile devices, and mobile telecommunication use services and networks that comply with International Mobile Telecommunication, which was specified by International Telecommunication Union. 3G telecommunication network supports services that provide an information transfer rate which is 144 kilobytes per second. Later, 3G releases often denoted as 3.5G, 3.75G. These are the enhanced version of 3Gs, that is 3.5G and 3.75G, which also provides mobile broadband accesses to several megabytes. This ensures it can be applied to wireless voice telephony, mobile internet access, fixed wireless internet access, video calls, and mobile TV technologies. This was about your 3G, which provides the high-speed transmission having data transfer rate more than 0.2 Mbps, and it is providing your global positioning system, which was first started in your 3G. We move on to your 4G, wherein 4G is also called as your evolution advancement. Nowadays, all kids, even if I have a smaller kid who is of class 1 or 2, will say that I am using a 4G mobile phone. They know how to open the phone, unlock your phone, put the password, provide the same hotspot sharing to your smart TV, and they can view the movie, whatever they require. That is the generation wherein the students or the kids are utilizing their mobile phones. That is thanks because of this 4G, wherein your 4G is providing a succeeding rate of 3G. So 4G system provides capabilities defined by ITU. Potential and current application include amended mobile web, IP technology, high definition mobile TV, video conferencing, and 3D televisions. So all these can be done using your 4G mobiles, which was a limitation in your 3G mobile. So your 4G mobile are also called as your long-term evolution advancement. Why are these called as long-term evolution advancement, which was commercially deployed by Oslo, Norway, which was in Sweden in the year 2009, and had since been deployed throughout most parts of the world, and however being debated whether first release version should be a 4G LTE or it should be a 4G LTE Advanced, wherein it is having few key features such as your IP switched network transmission, which is providing the transmission of your voice. In your 1G, it was only your voice. In your 2G, we have your voice and data, and later on, it is moving on to your signals, and the 4G is providing all the features together, which is including the voice, data, signal, and multimedia. The peak data rate, which is measured as I've already told you, it is 100 Mbps for high mobile stations, wherein these high mobile stations include your trains, your cars, and for low mobility stations, it is 1 Gbps. And it is providing your high resolution and high speed gaming also in your 4G. I'll try to play a small video wherein you will have a clear picture of the evolution of mobile phones. Is my screen visible?
Yes, ma'am.
This is a small video which is providing you a knowledge about how the evolution has been occurred from 1G, 2G, 3G, 4G, wherein they have included all the mobile phones which were designed and developed in each year.
Guys, you know this phone's camera is gonna be truly amazing.
The first 4G mobile was invented in 2007. was a short video wherein I would like to just present where the evolution of your mobile phone. The first generation, which had only the basic services as your analog-based protocol, and it was only providing your 24 kbps, whereas in your second generation, the design for voice was improved, along with your GSM and CDMA concepts were included in your 2G. In your 3G, your speed was increased up to your 2000 kbps, and it was designed for voice with data, your multimedia text, and your internet. In your 4G, it is designed primarily for data and your LTE, which is a through mobile broadband. Next, we move on to your 5G, which is your next generation mobile communication. Next, mobile communication. Prior to that, I would just like to introduce few points stating that in the mid-1990s, the internet has had a revolutionary impact on communication, including the rise of near instant communication by electronic mail, voice over internet protocol, telephone calls, two-way interactive video calls, discussion forums were all introduced in the mid-1990s. In 2007, Steve Jobs revealed the first iPhone to the world, and Apple paved the way for the aesthetic of modern smartphone. Before iPhone, it was your flip phones and your phones with the slit keyboard and screens were the normal one. We have already seen these phones in your video. A year later, a central application store with an initial 500 downloadable apps was launched, and currently there are 2 million apps available in your Apple App Store. The internet has made communication easier, and it has been made faster. It allowed us to stay in connect with people regardless of time and location. These concepts I'm saying regarding your 4G, it's accelerated the pace of your business and widened the possibilities within the enterprise space. It's allowed people to find their voice and express themselves through social media, YouTubes, and many more. As I can give a very good example of this webinar wherein I can provide my information or I can share my knowledge among you, wherein my voice is being modulated and which is being transferred to you wherever you are seated. This is the power of internet, which has connected and divided us like nothing before, which is connecting as well as dividing. Why am I stating this statement? Because we are virtually connected, but rather than virtually being connected, if you have physically been connected, we would have shared more knowledge when compared to your virtual connection. But due to this pandemic, we can just say the advancement of your 4G, 3G, and the advancement to your latest 5G, which is providing a better internet connectivity to connect with people who are far away. The first instant of your wearable technology was a hands-free mobile, which was launched in 1999, which became a piece of tech synonymous with city workers, which gave business people to provide an ability to answer calls on the go, most importantly, while driving. All these are because of all your enhancements of the generations. 10 years ago, the idea that you could make a video call from an item other than a phone would have been a dream. Now, with smartwatches, audio sunglasses, and other emerging wearable technologies, these capabilities are a part of our daily life. The next generation of your virtual reality has been around since 2016, but it's already shaken up communications. The beauty of virtual reality presence means you can connect to someone in the same space at the same time without the time sink and cost of travel, even if participants are on different continents. Virtual reality also helps to facilitate better communication. In a typical discussion, a lot of information is non-verbal communication, which can be transcribed in virtual reality. In addition, researchers suggest we retain more information and can better apply what we have learned after participating in virtual reality. Third generation is a natural communication language overcoming linguistic barriers as well as a technical jargon. These were about the importance of the communications which were provided by your 4Gs. Now we move on to your 5G, which is also called as your next generation mobile communication, wherein the fifth generation of mobile network Why do I call it as next generation mobile communication? Why? Because it promises much faster data download and upload speeds, wider coverage, and more stable communication. These benefits will bring out significant improvement in communication. Instant communication will be possible, and those patchy, frustrating video calls will be a thing of a past. Whenever I do a video call, I can see that I have a disturbance or delay, and those all will be waived off when I'm using 5G communication. The average 4G transmission speed currently available for our smartphone is around 21 Mbps mark, whereas 5G will be 100 to 1000 times faster. 100 to 1000 times faster. Your previous 4G was providing only 21 Mbps. If I say 100 times faster, then it will be 2100. 1000 times will be 2100. So your patchy video calls will be waived off. The downloading speed will be much faster, and so on. The Consumer Technology Association noted that at this speed, you could download a 2-hour movie in just 3.6 seconds. I have a next slide wherein I'll explain this exactly how this will happen. So everybody might be aware of the movie Star Wars. If I would like to download the same movie using your 1G in 1980s, so the time taken to download that particular movie would be 4 months, 27 days if I wanted to download the Star Wars movie. And the theoretical maximum speed would be 2.4 kbps. Whereas if I move on to your 2G, it would take how many days? It would take 5 days and 13 hours. Your months were reduced to days using your 2G. When I move on to your 3G, we can see that your days are reduced to hours if I'm using your 3G concept. When I move on to your 4G concept, I can see that I can reduce hours into seconds. I can download the same movie with 1 Gbps speed, and I can download the same movie within 30 seconds. Whereas if I move on to your 5G, I can download the same movie using how many seconds? I can download within 1.5 seconds. So you can see the improvement of your technology from 1G to 2G to 3G to 4G to 5, wherein if I would have still been in the outdated version of 1G, I would have required 4 months to download, almost 4.5 months to download the same movie. The same can be downloaded using 1.5 seconds. So 5G is being utilized in many of your mission critical applications. Suppose if I take an example, the first example as your telemedicine. Everybody might have watched the robot movie wherein the robot would do the operation. So this is possible only because of your 5G. It would help us in your telemedicine. Along with that, it would help us in your autonomous vehicles, wherein self-drivers and your better collision avoidance systems were being provided. Next, we move on to these are the applications of 5G, where all the critical applications I could utilize this 5G concept. Next one is your Internet of Things, wherein I can monitor the places and the processes. Next, I can use them in your drones. You can already see the drones are being utilized in your marriages and in your crickets and many more other places wherein the inspection and delivery of your supplies was difficult. Next, we move on to your industry automation, where the robots can communicate with others. Majority of human resources are being replaced by these robots. Next, we move on to your virtual and augmented reality. Already explained that as virtual reality is coming into next. So here he is explaining in your timeline, stating that in 2017, the info or communication medium conducted your first public consultation on the airwaves to be allocated to 5G. Whereas when we moved on to your 1890s, we had 3 telecoms, that is your single, and next one is your Star Hub and M1, which connected by using your 5G technologies. By the end of 2019, your 5G airwaves, which limited in supply, issued the 2 winning business proposals in your telecoms. This is the timeline wherein there is an improvement from one state to another, from other state, which first commercial 5G networks to be operated by least 2 winning telcos. And here we have in your 2023, your 5G network coverage must be at least 50% island-wide, and in 2025, more airwaves may be freed by the 5Gs. So here I would like to just highlight stating that if I have to move on to your 5G, I require your 4G. Why? Because immediately transferring or moving your data from 4G to 5G would be difficult. Based on this improvement, based on these possibilities of your 5G providing during the past decades, the Internet of Things has revolutionized the ubiquitous computing with multitude of applications built around various types of sensors. A vast amount of activity is seen in your IoT-based product lines, and this activity is expected to grow in years to come in projection as high as billions of devices with an average of 6 to 7 devices per year, 6 to 7 devices per person by year 2020. So here these are the statistics of 2020, with most of these issues at devices and protocol level solved during the past decades. There is now a growing trend in integration of sensors and sensor-based systems. In your 5th generation wireless systems are an horizon, and IoT is taking the center stage. Here I am just stressing 5th generation wireless systems are on the horizon, and IoT is taking the center stage as devices are expected to form a major portion of 5G network paradigm. The IoT technologies such as machine-to-machine communication complemented with intelligent data analytics are expected to drastically change landscapes of various industries. The emergence of cloud computing and its extension to fog paradigm with glorification of intelligent smart devices is expected to lead further innovation in IoT. These development excites us and forms a motivation to survey existing work, design techniques, and identify new applications of IoT. So researchers, scientists, and engineers face emerging challenges in designing IoT-based systems that can efficiently be integrated with 5G wireless communication. So our next topic would be, what is Internet of Things? The Internet of Things, or IoT, as everybody knows, everybody is aware of IoT, refers to billions of physical devices around the world that are now connected to Internet, all collecting and sharing the data thanks to the arrival of the super cheap computing or computer chips and the ubiquity of wireless network. Based on this only, I can turn anything into an IoT device, forming something as a small pill to something as big as an aeroplane into a part of IoT. Connecting up all these different objects and adding sensors to them adds a level of digital intelligence to devices. The Internet of Things is making the fabric of world around us more smarter and more responsive, merging the digital and physical universe. The Internet of Things, it's really a giant robot, and we don't know how to fix it. Pretty much any physical object can be transformed into an IoT device if it can be connected to Internet to be controlled or communicated. A light bulb that can be switched on using a smart app is an IoT device. Yes or no? I can switch on and switch off a tube light or a light bulb using your smart app in your IoT device, as is a motion sensor or a smart thermostat in your office. An IoT device could be a child's toy or a serious driverless truck. So it can be a minimal one or a maximum one. As I've already told you, it can be a pill or a plane. So here he is stating that the IoT device could be a child's toy or a serious driverless truck. Some larger objects may themselves be filled with many smaller IoT components, such as a jet engine that's now filled with thousands of sensors collecting and transmitting data back to make sure it's operating efficiently. At an even bigger scale, smart cities projects are filling an entire region with sensors to help us understand and control the environment. So the term IoT is mainly focused or used for devices that would not usually be generally expected to have an internet connection. For this reason, a PC isn't generally considered an IoT device and neither is a smartphone. So here I cannot consider a PC or a smartphone as an IoT device, even though the latter is crammed with sensors. A smartwatch or a fitness band or other wearable devices might be counted as an IoT device, however. So every day, everybody is having a smartwatch wherein they are trying to sense the number of steps, the number of calories burned, and many more things. This is the basic minimal one which everybody is having in their hand, and I can call that as an IoT device. So I would like to just brief out about what is the history of Internet of Things. Idea of adding sensors and intelligence to basic object was discussed in the year 1980s and 1990s. But apart from some early projects, including an internet-connected vending machine, progress was slow simply because the technology wasn't ready. Chips were too big and bulky, and there was no way for objects to communicate effectively. Processors that were cheap and power frugal enough to be all about disposal were needed before. The adaptation of RFID tags, low power chips that can communicate wirelessly solved some of these issues, along with increasing availability of bandwidth, internet and cellular wireless network. This is the connectivity between your previous slides and your next slides. The adaptation of your protocols, the IPv6, IPv4, this would be better understood by computer science background students, wherein the IoT is using the adaptation of IPv6, which along other things should provide an IP address for every device. The word indeed is ever likely to be needed was also a necessary step of IoT scale. Kevin Aston coined the phrase Internet of Things in 1999, although it took at least another decade for technology to catch up with the vision. It was already coined or framed in 1999, but this word became famous only after a decade, which refers to, here I am just briefing out, which refers to machine-to-machine communication, Skynet or Internet of Everything. The various components of IoT are your sensors, your connectivity, and people and process. So what are these sensors? Sensors or devices help in collecting very minute data from the surrounding environment. All of this collected data can have various degrees of complexities, ranging from simple temperature monitoring sensor or a complex full video feed. A device can have multiple sensors that can bundle together to do more than just sense. For example, our phone is a device that has multiple sensors such as your GPS, your accelerometer, your camera, but our phone does not simply sense things. The most rudimentary step will always remain to pick and collect data from the surrounding environment, be it a standalone sensor or multiple sensors or multiple devices in a single concept. The second one is your connectivity. The next concept is connectivity. That collected data is sent to a cloud infrastructure, but it needs a medium for transport. I have sensors which is collecting huge amount of data. It may be a single sensor or it may be multiple sensor which is providing me, as I have already given you an example of your jet, wherein I'll be using multiple sensors which on a whole collect huge amount of data and transfer the data to cloud. How am I transferring that data to cloud? The sensors can be connected to the cloud through various mediums of communication and transport, such as cellular networks, satellite networks, Wi-Fi, Bluetooth, wide area network, low power wide area network, and many more. Ever often, we choose specification and trade-off between power consumption, range, and bandwidth. So choosing the best connectivity option in IoT system is a major point. Next, we move on to your people and process. Along with people and process, I call it as data processing or people. Once the data is collected and it's getting into the cloud, the software performs the processing. I have to process that data. Why am I collecting that data? Suppose I'm collecting the satellite information. Why am I collecting the satellite information? Once the data is being collected, I process that data. This can range from something very small, such as checking that the temperature reading on the device, such as your AC or heater, is within an acceptable range. It can be sometimes also very complex, such as identifying objects such as intruders in your house using your computer vision or video. So here I am giving you the minimal example and the maximum example. That is, your minimal example is whether I have switched on or switched off my heater. The next one is identifying an intruder. So identifying an intruder is I should have a high definition camera which is recognizing the image which is not matching to the images of your people of your house. So all these processing is being done over here. So, but there might be a situation when a user interaction is required. So everything cannot be done. For a few, there is a requirement of a user. For example, what if when the temperature is too high or if there is an intruder in your house? So I can only detect that one. That's where the user comes into the picture. I can process the data, I can connect the sensors, I can collect the data, I can process the data. Can I avoid that person the intruder getting into your house? So that there comes the user. Okay. So next we move on to benefits of Internet of Things. So IoT is an important piece of technology that is set to improve greatly over time. There are many advantages of having IoT or things connected to each other. The few benefits I would like to list is dynamic control of industry and daily life, improve the resource utilization, integrating human, society and physical systems, flexible configuration, acts as a technology integrator, universal internet networking. So what is this? Here I can say that more data means better decision. With added sensors, these devices are able to collect a large amount of data on different areas. For example, in addition to practical elements of being able to know which foods are going out of date in your smart refrigerator. So more data means better decision. How am I getting the decision? I have taken an example wherein I am having a smart refrigerator wherein it gives me an indication that this item is becoming or going out of date. This enhanced household item will be able to give an additional information on its power consumption, your temperature, the average time of doors spent open, and much more. Many companies are realizing the power of this technology and it is leading to large increase in market. In fact, the total market value of IoT is setting to grow over $3 trillion annually by 2016. Ability to track and monitor things. So, as well as tracking data for a company to use, it also greatly benefits the user. These devices would have the ability to keep an eye out on the current quality of goods at home, knowing the state of your items without them having a consistently check the quality themselves. Having a device doing most of the work for your means that you can save more time and cost. Imagine having a fridge order a new carton of milk to be delivered when it reaches a certain level of expiry. So automatically a fridge is giving an order to deliver a carton of milk. So the lightning workload with automation. The lightning of your workload can be done using your sounds goods. Okay, this really reduces human effort. It also results in devices being created that need little to no human intervention, allowing them to operate entirely on their own. As I have given one example wherein I cannot avoid the intruder getting into my house. I can also do that using this can be done in your 2026. Next is increase efficiency by saving money and your resources. So how can I do that one? If lights automatically turn themselves off the moment you leave the room, you can save a lot of money on your electricity. As well as you see, connected devices can provide more useful implementation. The IoT system encourages machine-to-machine communication, resulting as I put it in the third slide of your IoT, machine-to-machine communication, resulting in increased long-term efficiency for both the company and user. Better quality of life, having your device track and order things. Having your device track and other orders turns your light switches off and on and help manage important tasks that you may not have time to do yourself, takes out a lot of stress in the people. What is the scope of your future scope of IoT? If you have any doubts, students or participants can post your doubts in the chat box. Next, I would like to brief out about the scope of IoT. Your Internet of Things has emerged as leading technology around the world. It has gained a lot of popularity in lesser time. Also, the advancement in artificial intelligence and machine learning have made the automation of IoT devices easy. Basically, AI and ML programs are combined with IoT devices to give them proper automation. IoT is not a single part, it has many things in collaboration. Due to this, IoT has also expanded its area of application in various sectors. Here in this section, we will discuss the application and future scope, such as healthcare, automotive, and agriculture industries. So as I've already explained in your 5G, wherein I told it would be helpful in your healthcare, we will see the future of IoT, wherein the IoT has proved to be one of the best tools for healthcare industry. It helps provide advanced healthcare facilities to patients, doctors, and researchers. These facilities include smart diagnosis, wearable devices for tracking health, patient management, and many more. Furthermore, IoT devices have reduced unnecessary strain on the healthcare system. The next point which I would like to stress on would be your agriculture. One of the three basic human needs is food. To fulfill the need for food, we do farming. However, as the population of the world is increasing, agriculture and industry is facing many challenges. So these challenges in weather condition and climate hugely impact the agriculture industry. To meet the rising demand for food, the industry has hence adopted technologies to increase productivity. It includes the use of precision farming, agricultural drones, and smart farming applications. Automotive industry, we had one initiative by Government of India, which was also called as Agri-India, wherein they had invited few of the new innovative projects done by students so that they can promote agriculture using your various IoT and your smartphone technologies. Next, we move on to your automotive industry. The application of IoT is revolutionizing the automotive industry. One of the major applications is the creation of self-driving cars that has engaged or changed the trend of automotive industry. Engineers have created self-driving cars to reduce manual errors and ensure safe drives. Various companies around the world are creating self-driving vehicles, including your Google, Tesla, Mercedes-Benz, Volvo, Audi, and many. These self-driving cars use various technologies and IoT devices are programmed in such a way that they assist in creating an automotive system for self-driving cars. The following are the key uses of IoT in business. So IoT is transformation force that helps the companies to improve. As I've already told you, it will be helpful in your medicine, in your agriculture, in your automotive cars. Along with that, it is providing performance through IoT analytics and IoT security to deliver better results. Businesses in utilities, oils and gases, and many more. So here I would like to stress on the key uses of IoT is improved decision making. These are the few places wherein I can use the IoT. When I'm using IoT in business, I can improve business decision making, understand customer, deliver new customer value proposition, improve and optimize operation, generate an income, and improve the value of business. How can IoT help? Real-time management of critical systems. This is the major place wherein I can utilize IoT. Where the IoT platform can help organization reduce costs through improved process efficiency, asset, utilization, and productivity. Along with that, making real-time management decisions at your critical systems. With connected IoT assets, enterprises capture vast troves of real-time data that help in tracking assets, products, and day-to-day operations. Extended business critical operation on mobile platform are leveraging enterprise mobility platform to enable real-time access. This data is helping enterprise and its consumers in taking better decision in real time. So I would like to give an example. In your cloud-based smart metering solution built around water meters are helping the utilities and its customers with water consumption data in real time. This system is helping the consumers in taking proper decision towards efficient water consumption. The growth and convergence of data process and things on the internet would make connection more relevant and important, creating more opportunities for people, businesses, and industries. Along with that, the automated waterwork systems, the disaster planning and recovery, wherein IoT implements for disaster management can turn out to be one of the greatest or biggest game-changing trend with IoT sensors and warning systems. This helps industries or businesses in making critical decisions. So IoT sensors can efficiently monitor the rise in level of harmful gases in certain industry units and automatically shut down the system with a raised alarm. So these are the few places where IoT is definitely helping or providing a major impact of influence. Next, we move on to your current state and future proposed IoT, wherein in the year 2003, world population was 6.3 and connected devices were only 500. Whereas in year 2010, more connected devices than people. We had 6.8 billions. It was double. That is why we have highlighted more connected devices than people, 6.8 billion, 12.5 billion. In year 2015, the population was 7.2, but the connected devices were 25 billion. But here in your 2020, we can see that 7.6 billion is the world's population and the number of IoT devices connected are 50 billions. Applications of IoT. Here, the applications of IoT are multiple because it is adjustable to almost any technology that is capable of providing relevant information about its own operation. Nowadays, many companies from different sectors are adopting this technology to simplify, improve, automate, and control different processes. Next, we show some of the surprising practical applications of your IoT. So these are the practical applications of IoT, wherein the IoT applications would be very much used in your education. Are we not using your IoT applications in your education, in your food, in your pharmaceuticals, logistic, retail, and management? As I've already discussed these examples, you name it and you will have it in IoT. Whatever we are naming, I can just connect, as I've already told you, any small handheld device with connectivity, and with your connectivity to the net as well as to the cloud will be named as a IoT device. Next, I would like to show the progress index, wherein how much more IoT can do if only left for your imagination. So what happens over here? In the first one, your smart house. Your smart house is using your smart thermostat, your connected lights, your smart fridge, and many more. So in your second one is your wearable devices, your smart watches, your wristbands, your wearable devices. Next is your smart city, your smart parking, your switching on and off of your lights and the garbage collection. All those come under these applications wherein your smart home is the very first one where the IoT devices are maximum connected. So as I have already told you the advantages, there are few challenges faced by the IoT. The present IoT challenges faced are the scalability, security, technical requirements, technological standard, your software complexity. Whether it involves smart home devices or smart business technology or industry Internet of Things, many challenges exist. The most significant and arguable unsolvable challenge relates to security, or more specifically cyber security, as it pertains to information technology. It's not just the data collection that is vulnerable, but everything connected to the actual hardware. So most online connections are secured using a form of encryption. What this means is that the data is locked behind a software key and cannot be decrypted or translated without the appropriate authorization. Some of the more basic form of encryption are easy to break, but they can still take long time, slowing down any parties. Ultimately, it means that encrypted data is and always will be exponentially more secure than raw, unprotected data. This can mean that sometimes the entire device or system are unusable. They might still operate, but at a reduced capacity. This is scalability. Worse yet, the data collection and reporting process are interrupted as well because of the technical issues. The electronic require energy to operate, and IoT devices are not exceptions. They must actively transmit data 24/7, which means support from other technologies, including network adapter, gateway, and it should be supported by other technologies which include the adapters and gateways. Beyond just electricity, data requires physical storage, even with cloud and edge computing solution. So data centers which require large-scale cooling system to operate under heavy load. All these are the challenges faced by IoT. Solution for these challenges is, while cybersecurity will never indeed be solved under the appropriate security measures, this means employing data encryption, strong authorization and access control, and even using advanced AI monitoring tool to regularly audit security. The only way to genuinely secure data and protect the privacy of all involved parties is to erase it from existence, because that's not possible. The next best thing is to employ strong data encryption and to minimize access point and gateways where the data is being sent or accessed to. So low power and offline support are certainly two features that should be prioritized for the IoT market. In the commercial world, there needs to be a reliable way to utilize devices and system under expected conditions. That requires a lot of testing, a lot of new use cases and formats, all of which service the always-on concept of modern technology, even in the face of limited resources. So these are the several solutions which we are providing. So some of them include the overcoming capabilities of the hurdles, such as your security and your safety, your scalability. The government industry body needs to set up few standards so that it is not being hacked or encrypted easily. The IoT needs strong authentication method for the encryption and the platform that can track irregularities on the networks. I would like to share a small video which will provide an insight . what actually IoT
Why
is.
not turn off the air conditioner while leaving your house? Instead of traveling all the way back home, what if you could use your smartphone to know the status of your AC? And perhaps even turn it off? Wouldn't that be amazing? Well, yes. And this can be achieved with the help of the Internet of Things. Until recently, access to the Internet was limited via devices like the desktop, tablet, or smartphone. But now, with IoT, practically all appliances can be connected to the Internet and monitored remotely. IoT is shaping the way we live our lives. It helps us get a better insight into the working of things around us. So, what exactly is the Internet of Things? IoT is a system of interrelated devices connected to the Internet to transfer and receive data from one to the other. A smart home is the best example of IoT. Home appliances like the AC, doorbell, thermostats, smoke detectors, water heaters, and security alarms can be interconnected to share data with the user over a mobile application. The user can now get detailed insight into the working of the devices around him. Think about it. Until recently, the Internet helped people connect and interact with each other. But now, inanimate objects or things have the ability to sense the surroundings, to interact and collaborate with one another. For example, in the morning when your alarm goes off, the IoT system can open the window blinds, turn on the coffee pot for you, and even turn on the water heater. Although all of this is fascinating, there's a lot that goes on in the background to ensure seamless functioning. From effective communication between devices to accurate processing of the data received, a lot of components are involved. In the context of IoT devices, hardware can be classified into general devices and sensing devices. The general devices are the main components of the data hub and information exchange. They are connected either by wired or wireless interfaces. Home appliances are a classic example of such devices. The sensing devices, on the other hand, include sensors and actuators. They measure the temperature, humidity, light intensity, and other parameters. These IoT devices are connected to the network with the help of gateways. These gateways, or processing nodes, process the information collected from the sensors and transfer it to the cloud. The cloud acts as both the storage and processing unit. Actions are performed on the collected data for further learning and inferences. Wired and wireless interfaces like Wi-Fi, Bluetooth, Zigbee, GSMs, and so on are used to provide connectivity. To ensure its ubiquity, applications need to support a diverse set of devices and communication protocols, from tiny sensors capable of sensing and reporting the desired factor, to powerful back-end servers that are utilized for data analysis and knowledge extraction. To help you understand its working, let's take a simple scenario. Let's suppose you want to water your garden every time the moisture level in the soil drops. Instead of doing it manually, you could automate it using IoT. The sensors and actuators installed gauge the soil for its moisture. This information is sent to the IoT gateway with the help of communication protocols like MQTT or HTTP. The gateway significantly aggregates data and feeds it to the cloud with the help of Wi-Fi LAN. Once the moisture level drops, the system is immediately triggered and the sprinklers are turned on. However, with the information stored in the cloud, a detailed analysis like the time of the day the sprinkler was turned on, the rate at which the moisture in the soil reduces, and so on, can be done, and the report could be sent over to you on your smartphone over an app. With the improved response, monitoring, and analytical capabilities, IoT is being adopted in almost all industries and domains, opening doors to endless applications. Today, IoT is being used extensively to lessen the burden on humans. To name a few, IoT is deployed for smart homes, wearables, watches and bracelets, smart cars, smart farming, smart retail, smart grids, smart city, and smart healthcare. With such a wide spectrum of applications, the future of IT looks more promising than ever before. In 2018, there were about 23 billion connected devices, which was more than double the world population. According to experts, there will be over 80 billion devices by 2025. IoT is a vision to connect all devices with the power of the internet, always learning and always growing. Now that you have a picture of what IoT is, here's a simple question for you. Which of the following technologies is not used as an interface for a network? 1. Wi-Fi. 2. Ethernet. 3. Zigbee. 4. VPN. Give it a thought and leave your answers in the comment section below. 3 lucky winners will receive Amazon gift vouchers. The integration of IoT with other technologies like cloud computing, machine learning, and artificial intelligence is paving the way for many new and exciting innovations. And that is the Internet of Things for you in short. If you enjoyed this video, a thumbs up would be really appreciated. Don't forget to subscribe to the Simply Learn channel and hit the bell icon to never miss an update on the latest trending.
Yes, madam. If anybody has any comments, can just discuss, or you can collect the comments and mail them to me. I would reply back. I would like to thank the organizers and publishers who gave me an opportunity to present my knowledge or share my knowledge among the participants. I would like to acknowledge my thanks to Dr. J.P. Agarwal, JNI2IT, and Nagaraju Baiditi, NIT. They had been a driving force from whom I got motivated and I presented this session. Along with that, I would like to provide a special thanks to our college GSSSIETW, HOD, and all my colleagues who created an atmosphere or provided an opportunity to do my presentation in a better way. Thank you. Madam.
Thank you, ma'am. Thank you very much for the wonderful session. The participants, I have posted the feedback form in the chat box. Please do fill it out.
Yes.
Thank you very much to all the participants for the patient listening. Thank you, ma'am.
Thank you, madam.
Is the session over now? Can we leave? Thank you for this great session. Yes. Thank you for this great session.